Hi dear students, how are you? I hope you're fine. Today we are going to talk about angle relationships in circles. So we are still here in chapter 11 about circles. So if I have here inside a circle, I have here two chords or two seconds intersect each other at a point inside the circle. So the angle formed here, as you see, angle 1, it's equal to what? Equal to half of the measure of arc AB plus arc CD. So this angle 1 here is half of arc AB plus arc CD. Okay. Okay, so if he gives me a question like this problem, he asks you here to find what? Measure of angle AEB. AEB. AEB, this angle. So, what do you think AEB equals what? We said here, if I find here two seconds or two chords intersect each other inside here, inside here, the circle. So, you will find that this angle, remember angle 1, will be equal half of the sum of the two arcs here formed, arc AB plus arc DC. So measure of angle AEB equal half arc AB plus arc CD. Right, and then I will substitute here instead of AB I will write 139, instead of DC I will write 113, add them gives you 252, half of 252 gives you 126. Easy. If I have another problem here, he asks you to find what? To find measure of angle ABD. ABD. So this measure of angle. So what do you think? I have here intersection between a second and a chord. So what do you think? What will happen? It will be half of AD arc plus EC arc. So I will substitute here the values of AD and C and CE, and then calculate half of the 102 gives you 51. We have here another one. If I have here another theorem, we got if a tangent and a secant, two tangents or two seconds intersect in the exterior of a circle. So we have here the intersection here outside the circle, or then the measure of the angle formed is what? The measure of angle formed here for angle 1, for example, okay, half of the difference between the intercepted arcs. So again, if I have here an intersection of the seconds, if the intersections of the seconds and the tangents, okay, so we can have tangent and a second, okay, tangent and a second for the first one. I can have here also what? Two tangents in the second one, and I can have here two seconds in the third one. So all these intersection give me what? Gives me here outside, they intersect in the exterior of the circle. Then the measure of the angle formed is what? Half the difference of the measures of the intercepted arcs. So now external difference, and what about the internal? Internal sum, external difference. So I'm going to say here I have AD minus BD, AD arc minus BD arc. Measure of angle 2, half of what? Half of EFG arc minus EG arc. What about this one? Angle 3, JN arc minus KM arc. Okay, easy, I think it is. Let's have an example here. So if given here, he asks me to find measure of angle X. So measure of angle X here is exterior angle. So I got here what? I got here the two seconds here intersect outside the circle. So this measure of angle equal half the difference between GC and what? And here DF. So the half of CG arc and DF arc. So 87 minus 7 gives me here half of them, gives me here 40, half of the 80. What about this one? He gives me here X, the outside here a tangent and a secant for this. So we have here what? We have here measure of angle X equal what? I want to show you half the difference between AD arc minus BD arc. I think it's easy, right? Okay. And I have here for this example, I have here to find the measure of angle L. He asks me to find here X. So how can I find X here? I know that measure of angle L is what is 25, and we know that 25 measure of angle L equals half the difference between here JN arc minus what? Minus KM arc. So it will give you here 33. So instead of JN, I will write, instead of this, I will write 83. Easy one? I think it is. Okay, let's have this one. If I have here a measure of angle ACB. So ACB here, as you see, he asks here for ACB, this one. We have here two tangents. So it will be the difference between what? The difference between AEB minus half of the difference between AEB minus what? Minus AB arc. And given here the values, so it's very easy to find ACB. So you have here 225 for what? 200 AEB, and I have here 135 that I have here given. Okay, let's have another here theorem. So I have here the summary here of what? Of the angle relationship. Okay, so I have here on a circle, if you have here the measure of angles, the vertex of the angle on the circle, so it will be what? It will be half of the intercepted arc. So if I have here, this is 120, therefore measure of angle 1 is 60 degree. And here also the vertex of the angle is on the circle, so it will be half of the intercepted arc, gives you here 100. What about if I have here the vertex of the angle inside? So this is the vertex of the angle, so this is inside the circle, so I will say in this one that measure of angle 1 here, measure of angle 1 here is what? Half the sum of the two here arcs, half of the sum of the two intercepted arcs, 86 plus 44. Okay, what about here if I have the vertex of the angle outside? So the vertex of the angle is outside, it will be what? It will be the difference, equal to half of the difference between the two intercepted arcs, so 202 minus 78. Okay, and for this one also, measure of angle 2, it's what? Equal half of 125 minus 45. Okay, very clear. Okay, outside, inside, and on the circle. So we have